development. If you've always had a keen interest in full-stack web development, then you've come to the right place. This course has been designed for both beginners as well as experienced web developers who seek a practical approach to web development. In this course, we learn all the fundamentals of web development and learn to code from scratch. We'll begin by installing and exploring our scripting environment, after which we'll move on to programming languages of the web. Now, this includes HTML, CSS, JavaScript, and even PHP. We'll cover both front-end and back-end technology stacks. Throughout the course, we'll develop a bunch of interactive web applications that you can add to your profile to strengthen your credibility as a full-stack web developer. From responsive e-commerce applications, styled booking systems, and even HR systems, rest assured that this will be a hands-on course. As a bonus, you will also learn all about SQL databases and how to integrate them into your website. In today's lesson, we explore the use of operators in JavaScript. Operators are an excellent way to perform arithmetic computation or operations. It's also a core part of JavaScript in that it allows us to implement conditional logic in our code. So come prepared with your thinking hats and prepare yourself for some basic algebra. Once again, a warm welcome from all of us here at Show Academy, where we are here to help you learn the skills you need to succeed today. Now, in today's lesson, lesson 3, we will be covering JavaScript operators as well as conditional logic, and the two can be quite powerful when used together. We will also be doing a practical in the session, or rather at the end of this lesson. Now, with that being said, let's have a look at what we have in store for today's lesson, lesson 3. So first of all, we will be working with JavaScript operators, and JavaScript operators are extremely important when it comes to using conditional logic. JavaScript operators allow us to either assign data, compare data, or perform some sort of arithmetic computation. And this brings us to our next point, where we will be implementing conditional logic inside of our code. And here we will look at things such as if statements, else statements, as well as the switch statement. And then lastly, we'll have a practical demonstration to bring all of this together to show you just how powerful operators as well as conditional logic is when used together. Wonderful. Now, without further ado, let's dive into our very first topic for today, and that's working with JavaScript operators. Now, first of all, what are JavaScript operators? Well, essentially, JavaScript operators are used to assign values and compare values, and we can even perform arithmetic operations using JavaScript. And this includes things such as addition, modulus, or even subtraction. And then lastly, we use operators in the event that we want to implement conditional logic inside of our code. And when we get to the section, we will be covering if statements, else statements, as well as switch statements. You will really be able to see the power behind using operators and conditional logic combined. Wonderful. Now let's take a closer look at the different kinds of JavaScript operators available to us. First of all, we have arithmetic operators, and these are used to perform arithmetic between variables or even values. And this includes maybe subtracting one value from another in the event that we have two variables stored with two different values. We could even perform things such as addition or even modulus, as mentioned before. We also have assignment operators, and these are used to assign values to JavaScript variables. Now, we have been working with the most basic and the most common one, where we essentially just set a value with either a string or even a number data type. Okay. We also have comparison operators, and these are used in logical statements where we want to determine if something is equal or if there's a difference between the two. And this includes things such as greater than, less than, equal to, and so on. And then lastly, we have logical operators, and this is used to test if one or more conditions are met when comparing variables. So you would generally get a boolean as a result, and that could either be a true value or a false value, if you remember correctly from our previous lesson. Excellent. Now let's take a closer look at arithmetic operators and how we can use them in JavaScript. And here we have a very basic table with the various operators, and these symbols actually signify the operators and how we use them inside of our code, starting with addition. We also have subtraction, multiplication, we have division, we also have modulus, which gives you the remainder after dividing one variable across another. Then we have plus plus, which implies incrementing a value, so 1, 2, 3, 4, and then decrementing a value, which is pretty much the reverse of increment. So if we wanted to decrease a value step by step, say from 5, 4, 3, 2, 1, we can do so using the decrement operator. But if we have a look at a code snippet like we have over here, it tends to make a lot more sense when we apply our arithmetic operators. So in this example over here, we've got various operators with examples and then the actual output. Now our top image over here with our code snippet gives us variables that we've created. So let's assume for this example that we are working with the variables above. Now first of all, we have this variable called x, y, and z, where x equals 5, y equals 10, and z is currently undefined, meaning it does not hold a value. We also have another set of variables called counter1, which equals 6, and then we have this variable called counter result 1, which is undefined at the moment. Likewise, we have counter2, which equals 9, and counter result equals 0 or is undefined at this time. Now let's work through each of these examples and let's see how we can actually work with operators, or specifically arithmetic operators. And in our first example over here, using addition, we're essentially saying z or z is equal to the result of what x is plus y. And then we alert that result, which is z, and our output is 15. Now, if we move over to subtraction, we are pretty much doing more or less the same thing, where z is still currently undefined, and what we are saying is y, which is equal to 10 minus x, and we alert the result as z, which gives us a value of 5. Great. Moving on to multiplication, what we have is, again, z being undefined in this moment is y minus x multiplied by 2. Now here we are using BODMAS, and we know this because we've added brackets. So essentially what we are saying is, we are saying 10 minus 5, which is equal to 5, multiplied by 2 gives us 10. Okay, so the alert or the result that we are outputting is the z result, which might have been undefined in the beginning. But remember, in our first line of code in each example, what we are saying is assign the result of whatever arithmetic operation we are performing to z. Wonderful. Now, if we move along to division, it's pretty much the same thing again, where we are saying x plus y divided by 2, which is 5 plus 10 divided by 2, alert the result which has been assigned to z, and that gives us 7.5, a float. And then modulus works slightly different. So with modulus, we are alerting something and not assigning something to our z variable. Essentially, we are alerting y modulus 3. So let's have a closer look here. Now, what is essentially happening here is that y is currently equal to 10. And then when we say divide that by 3, we want the remainder, which is 1. Because if you know basic maths, 3 can go into 10, well, that's the unofficial way of saying it. 3 can go into 10 3 times, which gives us a remainder of 1. And likewise, in our second example with modulus, we are alerting x plus y, which gives us 15, divided by 4 gives us a remainder of 3, because 4 can go into 15 3 times, which gives us a total value of 12, and this gives us a remainder of 3. Lovely stuff. Now, our last two examples, increment is pretty straightforward. We are essentially saying increment counter 1, right? And then take the counter result, which is undefined, and set that equal to the result of counter 1 after incrementing it, then alert that result, which is 7. Because if you have a look at our code, counter 1 is actually equal to 6, but once we increment it, it now is equal to 7. Likewise, with decrement, it's exactly the same thing. We've got a variable counter 2, which we are decrementing. We've assigned that variable to counter result 2, and then we've alerted the result, which gives us 8. And this makes sense, once again, because counter 2 is initially equal to 9, but once we decrement it or subtract 1 unit of value, we get 8. Now moving on to assignment operators, and here is a table that shows you a couple of examples of the assignment operators that we tend to use mostly in JavaScript. Now keep in mind, assignment operators are used to assign values to a variable, and we've done this pretty well with the very first example, which is equal. And in this example, essentially what we're doing is we've created two variables, x and y. X equals 15, y equals 3. But now what we've done is we've reassigned a value to x, and we are saying x is actually equal to y. So if we console log the result, or if we console log the data in x, this will output the result 3. So x is no longer equal to 15 and instead equal to y. We can even do some sort of addition where we can say x is equal to the result of x plus y, and this outputs 18. Next, we can do multiplication as well, which is quite powerful. And essentially what we are saying is x multiplied by y gives us the result or the new result assigned to x, which outputs 45. And then lastly, we can also perform an assignment operation using modulus. And in our example here, we are setting x equal to the result of dividing x by y, which gives us 0, because there is no remainder after dividing 15 by 3. Now moving on to comparison operators, and these work slightly differently. Once again, we have a table here that distinguishes between the various operators when it comes to comparison operators that we can use in JavaScript. Starting with the first one, we have equal to. And remember, when it comes to comparison, we are not assigning values, we are checking. Hence the double equal sign and not the single equal sign. The single equal sign signifies that we are assigning a value. Here we are comparing or checking values. And in this example, we have x which equals 100, y which equals 85, and we are console logging the result to see if the two are equal. Our output here would be false, which is a Boolean value. Next, we have equal value and equal data type. And here we have triple equal signs. Now this one is slightly different, actually vastly different, because we are checking not just the data type, but also the value. And if you have a look at an example over here, we have x which is equal to 85, we have y which is also equal to 85, but when we console log the result after checking if they are equal, it says false. Why is this the case? Because y is actually a string. If you look closely, we have it in quotation marks. Therefore, the data type is not that of a number. And then next we have not equal to, which is kind of the reverse of what we've been doing so far, where we have x is equal to 100, y is equal to 85, and then we are checking, is x not equal to y? This is why we use the exclamation mark. And the output is true because x is greater than y in this case. Okay? And then in our very last example over here, we have x which is equal to 100, y which is equal to 85, and we are checking whether y is less than or equal to x. And if we have a look at an example, 85 is indeed less than 100. And as our last type of operator, we have logical operators. And once again, here is a list of those operators. First, we have double ampersand, which implies and. We have two concatenation bars, which implies or. And then we have an exclamation mark, which you've seen before, which implies not. Now, let's have a look at a couple of examples. In our first example, we have two variables set in a single line. This is just a shorthand way of creating variables, where x is equal to 12 and y is equal to 35. Now we are console logging, or rather asking the question here, is x greater than y and is y less than x? Yes, this is true, and therefore we get an output of true. Now, the one thing about the ampersand or the and operator is that both conditions must be satisfied for the result to be true. So if x is greater than or less than y, while y is something completely different like equal to x, this would default to false because both conditions are not being met. Now here's an example of how that happens. Again, we have x which is equal to 12, we have y which is equal to 35, and now we're asking the question, is x less than y? Which is the case because 12 is less than 35, and is y less than or equal to x? This is not true, therefore the output, the result, is false because both conditions are not being satisfied. Now if we move on to or, this works differently. We've got the variable x again, we've got the variable y with the exact same values assigned to it, and we are asking the question, is x less than y or is y less than or equal to x? Only one of these conditions are true, and that's the first one, therefore we get a result of true. So if we compare the and the or operator, they work differently in that the and operator needs all, if not both conditions to be satisfied. With the or operator, we need at least one condition to be satisfied. Okay, that is extremely important to remember. And then lastly, we have the not operator, where we are asking the question, is x not less than y? Which is false, and this makes sense if you think about it, because x is less than y in this case. Outstanding. Now let's move on to our next topic for this lesson, implementing conditional logic. And here we are going to learn all about pseudocode, as well as if-else statements, as well as switch statements. Now you might have heard of this term called pseudocode in programming, but what exactly is it? Well, pseudocode is a text-based design tool that helps software developers build logic into their code or their program. And the way it works is you would generally just jot down something in black and white in sentence form typically to demonstrate how you want the conditional logic of your code or your system to work. Now, let's have a look at a quick example of how we can apply pseudocode to an actual if-else statement. Okay, and here we have a very typical example. If it's raining, carry an umbrella. That's one condition. If it's sunny, we would go for a swim, right? Because it's extremely hot. If it's snowing, we would grab a shovel and start cleaning up. And well, if we don't know what else it could be, we would just go about our day. The idea here is that there are certain conditions and certain outputs associated with certain conditions. In our first example, the condition is if it's raining, the result should be that we would want to carry an umbrella. And this is how we can actually use pseudocode to build logical systems. Now let us briefly discuss conditional logic to understand why it's so important. And essentially, very often you may want to perform different actions for different decisions. And to achieve this, we tend to use conditional logic. Now, I want to simplify this for you so that you can sort of try to understand a little better. If you think of a game of chess, you have a certain amount of moves and so does your opponent. Whatever move you or your opponent decides to make is going to determine the next move. And this is essentially how you can think about conditional logic. If something happens, you are going to expect the end result to change or the outcome to change. And we can do this by using things such as if statements, else statements, and so on. But let's have a look at what these statements actually are. Now, here are the key conditional statements that we tend to use in JavaScript. First of all, we have the if statement, which is used to specify a block of code to be executed only if the condition is true. Next up, we have the else statement, which is used to execute a block of code if the if statement is not true, then results in false. We tend to use the else statement. We also have the else if statement, and this one works slightly differently, and I will show you an example here. We use else if to test a condition if the first condition is neither true or false. Now again, that might not make sense, but when we have a look at an example, it's going to make a lot more sense. And then lastly, we have the switch statement. And we tend to use the switch statement if we have a known amount of outcomes or possibilities. We would use the switch statement to jot down those possibilities so that the various conditions, when met, will have a certain result or output. Now, here is a typical example of how we can actually use the if statement in code. Now, before we jump into the code, let's build a quick scenario. Let's, for argument's sake, say that you would like to go on a roller coaster ride, but to actually go on the ride, you need to be a specific height at least. So in our code, how we demonstrate this is that we create a variable called height centimeters, and this essentially just holds a value of 165. Now, if that is my height, I can then test it in a conditional statement, which says if my height is at least greater than 160, then console log, you are tall enough to go on this ride. And this is what the output looks for, something like that. We just console log it to our console element inside our client. And this is just a typical, very basic example of how we can test a condition using conditional logic in JavaScript. So then what about the else statement? How do we actually use the else statement in conditional logic? Well, here we have an example of what the code would look like, at least the pseudocode would look like for something like this. If the condition is true, then run this block of code. Else, if the condition is false, then run this block of code, which would be the alternative if our first condition is not met. Now let's turn our attention to an example of using the else statement in code. Now I've maintained the same variable on top where my height in centimeters is 165. The scenario remains the same. However, my first if condition changes. So I've changed it from 160 to 170. So if height in centimeters is greater than 170, then yes, I'm allowed to go on this ride. Else, if it's less than 170, then sorry, you are not tall enough to go on this ride. And this is what the output looks like for that. So let's just run through the logic here. My height in centimeters is 165. I need to be at least 170 centimeters to actually go on this ride. So testing the first condition, that is a fail or returns a false. Therefore, we default to the else condition, and then we get the output once again, sorry, you are not tall enough to go on this ride. Wonderful stuff. Now, next up, we have the else if statement, and this is how it works. So if condition 1 is met, then run this block of code. If that condition is not met, then check the next condition. So we have another if condition, but it's an else if condition, which is condition 2 in this case. And if this condition is true, then run this code only if condition 1 is false. Okay, moving on, else run this block of code. So if all conditions above fail, run the else statement as a sort of last resort, if you will. Okay, now there is a trick to the else if statement, and I will demonstrate this in an example of code. So let's have a look. Now let us assume the exact same scenario, and that is that our height remains exactly the same, 165. If the first condition is met, then it would generally run this condition. So if my height in centimeters is greater than 167, then you are tall enough to go on this ride. Great stuff. That is what we would have gotten. Okay. Now, if that condition is not checked or not true, then move on to the next one. Else, if the first condition that we tested is not true, check this one. My height in centimeters must at least be equal to 165 or greater. So if that is the case, then we'll make an exception. So enjoy the ride. Awesome. Now we also have another else if condition here, which is else if my height in centimeters is less than 167, which is the case, then we should be getting this code. Try a different ride. If all conditions fail, then sorry, you are not tall enough to go on this ride. And this is the output that we actually get. Now, let's just have a look here and unpack this to see what's going on. So we have two conditions that are being met. The two else if conditions. First of all, my height is at least equal to 165 and not greater, but that is one of the conditions. And the second else if says, if my height is less than 167, then try a different ride. Now, essentially what's happening here is the moment the code meets a condition that's an else if, that is the first else if condition, the code will stop running. Therefore, we'll never get to the third or the second else if condition, even though this is true. Because remember, my height is less than 167, but I'm not getting this output in my console log. Why is that? Because the first else if condition is already being met, therefore the code will stop running. Now this is extremely important to keep in mind when working with else if. And now for our very last conditional statement, the switch statement. So this is what the code looks like for a switch statement. First of all, we open it up with the switch keyword and we specify the variable or the condition that we want to test. And then we move on to the next block of code, which says case X, do the code that you want, then break. Now let's have a look at what's actually going on here. So what we are saying is we've got our condition that we specified earlier on, which is the condition over here. Then we're saying in the case of X, if this condition holds true, run this block of code and then break out to the switch statement. If the condition is not met here, then move on to case Y, check that condition. If that condition is met, run the code and then break out to the switch statement. And then likewise, the exact same applies for case Z. If none of these conditions are met, we then have some default code that we can actually run. Now, again, let's have a look at a code example. For this example, let's consider our pseudocode that we had earlier when it came to the weather and making certain decisions. So in this code snippet, the first thing we have is this variable that we created, which is called weather. And this takes in a prompt. Now, if you remember from our previous lesson, a prompt is a user input element and basically takes in all the data that the user punches in and processes that data. Okay, so we are assigning a prompt to the variable called weather. We are then testing the switch condition on that variable that we just created called weather. Now, in the event that the user passed in sunny, we would then alert go for a swim. If the user passes in the word rainy, then we would output something like don't forget your umbrella. And if the user passes in the text snowy, we then alert to the user, grab a shovel and get to it. And then lastly, if the user passes in just a bunch of gibberish or something like it's extremely hot, then we output something a little weird like, I can't help you there. Wonderful. Now, I hope all of this makes sense because we're going to move on to our practical. But before we do that, let's have a look at what's coming up in our next lesson. In our next lesson, we tackle one of the trickiest concepts in programming, otherwise known as loops. In JavaScript, loops are particularly powerful in the event that we want to save time writing code or if we are required to perform tedious tasks indefinitely. In this lesson, we learn all about the three basic loops, the for loop, the while loop, and the do loop. And now for our very final topic in this lesson, our actual practical demonstration. And I'm sure this is something you've all been looking forward to. So without further ado, let's code. Now, before we get started, let's have a look at what we're actually going to be working towards in this practical. And essentially, we are going to be working towards developing a grade calculator. Now, for the most part, we are not going to be working with this column, and we are not going to be working with this column either. We are only going to be working with the first two columns where we have our grade as well as the percentage associated with that grade. Okay, so the idea is that when the user actually inputs some sort of data or a number, like let's say 50, they then get a response like, come on, you can do better than obtaining an F. And likewise, if they enter something like 95%, they get something like, congratulations, you obtained an A. So the idea is that we are going to build this grade calculator out based on the requirements or based on the specifications that we have over here. So without further ado, let's dive in. Now, in this tutorial, we are going to be working in JS Fiddle. And if you remember from the previous lesson, JS Fiddle is essentially our sandbox where we can test our JavaScript code. Okay, now before we get started, I need to create a variable called mark. And this variable is just going to hold the mark of whatever the user decides to pass into the prompt box. So in this case, I'll say var mark equals prompt. And then whatever I want the prompt to specify, something like enter, just get this correctly. Don't forget your quotation marks because we are working with a string. Enter your mark to receive your grade. Wonderful stuff. Now, if I save this, or I don't necessarily want to save this because it's on the cloud, I can actually just run this. And then I get my prompt. But because I don't have any code after this, it's not really going to do much. So it doesn't make sense to actually work with this. The idea is just to make sure everything is working correctly. Wonderful. Now, the first thing I'm going to do is I'm going to open up my first if statement. And I'll say mark is if mark is greater than or equal to 90, then do whatever the next line of code is going to be. And I will just specify over here. Then alert that is actually just open this up just to make it look a bit neater. So if the mark is greater or equal to 90%, then congratulate the user and say something like congratulations. Let's just spell this right. Congratulations. Did I get that correct? Yes, I did. Congratulations. You obtained an A. Wonderful stuff. Moving on, our next condition. Now, if we have a look at what we have over here, if the user gets anywhere between 90 and 100%, they should be granted an A, or they should be given an A. If they get anywhere between 80 and 89, they get a B, and likewise with C, they get 70, between 70 and 79, and so on. So essentially, we are going to be working with these two columns. Let's minimize that. And else if actually, because we are testing a different condition if the first one is not met. So else if mark is greater than or equal to 80, then do this. Alert to the user don't forget your quotation marks, well done, you obtained a B. Great stuff. Now, next condition, else if that condition fails, then check the next condition. Else if mark is greater than or equal to 70%, or 70 in this case, then do the following code. Okay, so what we can say is alert, quotation marks, actually didn't forget it this time, wonderful, alert, not bad, you obtained a C. Let's actually remove that because we don't want to be too excited about the C. In most cases, I think people tend to get excited about a B or an A. And then next condition, else if this condition is met, which is if the mark is greater than or equal to 60% or 60, then do the following code. Alert to the user, quotation marks, that, a 60% is not as great as a 70 or 80%. Well, that's mostly the case in academics. So you obtained a D. Better luck next time. Positive reinforcement, right? And then I'm thinking for our last condition, or our second last condition, we can have something like else. If the previous condition is not met, then do this. If the mark is greater than or equal to 0. Now, here's the tricky part. We need to set a lower limit. I haven't set an upper limit, but I'm going to set a lower limit. And the reason for this is because you can't get a mark of -1 or -2 or -5 or -100. It just doesn't make sense. So I'm going to use a logical operator here to test for two conditions that must be satisfied. Okay, so if the mark is greater than or equal to 0, and if the mark is less than or equal to 59, okay, then do the following, because you can't get less than 0, okay, and generally speaking, you can't get more than 100%, but I'm not going to set an upper limit in this example. I just want to do this once so that you get an understanding of how we can actually use a logical operator to make our code more versatile. So what I will say then is alert to the user, come on, you can do better than obtaining an F. Okay, wonderful. And then our last statement. Now remember, we are going to test this statement first, then we are going to move down our code over here to make sure that we at least find one condition. If none of these conditions are satisfied, then we must have an else just as a sort of default, okay? So I'll say else, curly brace, else if all else fails, alert to the user. Let's just space this out correctly. Alert to the user that you have entered an invalid mark. Let's just make sure all my spelling is correct. Invalid mark. Great stuff. Everything seems to be fine. Now we can actually run our code and test it. But before we do that, let's have a look at what's going to happen. So I'm going to be prompted to enter a mark. And based on the mark I'm going to enter, it's going to test these various conditions that I have set up here. If all these conditions fail, it's going to default to the else statement, okay? If the first condition is not met and the second condition is not met, but the third condition and the rest of them are met, then it's going to default to the third one. That's the point behind the else if statement. So let's actually just copy our code. Oh, damn it. Copy our code, make sure everything's running correctly. And if I run it now, I'll get a prompt. Let's enter 1. Come on, you can do better than obtaining an F. Great, that works. And how do we know this? Because we are satisfying this condition at the bottom. And if I run this again and I enter something like 99, congratulations, you obtained an A. Wonderful stuff, which is my hope for all of you guys, by the way. And then let's test it one more time. And let's go with something obscure like 73%. 73%. Not bad. You obtained a C, which is perfectly fine. And that's exactly what we specified here because we are satisfying this condition. Therefore, we are getting the output below that, which is this one over here. Wonderful. Now, that's a very quick tutorial on conditional statements. As we progress through this course, when we get involved with loops and arrays and objects and functions, we are going to be using if statements quite a bit. You might be asking yourself, why did we not cover switch statements? Well, the reason for that is in most cases, as developers, we tend to use if and if else statements because we don't always know the outcome of the thing that we're trying to achieve. And that is generally why we use switch statements. And switch statements are really amazing. They're really good. But for the most part, you'll most likely find yourself using the if and the if-else statement. Now, it's extremely hard to believe that we've come such a long way. We've officially wrapped up lesson 3. In our next lesson, we will be tackling loops as promised. So remember, this is going to be a tricky section, and I do want to encourage you to attend. So for all of that and more, I'll see you in the next lesson. Cheers.